study mind over matter, right?
We have attempted to study that. And that is correct, that we have. So the term mind over matter is a bit loaded. So let me be a bit more precise about what it is that we are attempting to study. What we have attempted to study is the plausibility of conscious control that might be exerted over modulating physiological states of the body. And so if you imagine that we conventionally think of conscious control as mind and physiological states as matter, then you might think of us kind of trying to study this idea of mind over matter. I don't know if I made that clear.
Indeed. And so how did this ability to control states of the body come about? Is this universal on planet Earth? Can everyone control their bodies?
How long has this technology existed?
Well, we all, to a degree, are able to. So again, we have to be careful in kind of defining what we mean by control. So there are two aspects of control. So, we feel cold or we feel hot, but we tend not to mind that. Or we might feel pain, but we tend not to mind that. That is a form of control, but that actually does not modulate or modify the actual physiological processes that are being perturbed. Okay?
So you're saying that simple tolerance of discomfort is a form of control?
It is a form of control over our responses to discomfort, but it is not control over what is actually at play at what I would generally call the subconscious or the unconscious aspects within the brain.
So this is like a psychiatric aspect of it.
But it's affecting the body's physical situation as well, it seems like.
So I think that's an unknown. So in fact, that's kind of what we have been interested in our work. And so this work that we are doing, my colleague Auto Music and I, we have been in very small steps trying to understand this question in a very, very peculiar model. That is this idea that you might be able to exercise control over, to some degree, over some basic aspects of thermal regulation. That is how our body responds to changes, externally induced changes in specifically cold is what we have been talking about or working on.
So why did you guys pick the cold to study as a stimulus?
Well, cold is actually really one of the more fascinating environmental stressors. I mean, for most of us, given where we now are in our stage of evolution as a species, cold or the feeling of cold really evokes a sense of extreme discomfort. And for example, we frequently say colloquially that, oh, I shudder to think of something. Well, when do you shudder? You shudder when you're cold. So in a sense, this fear of cold has kind of permeated the way in which we even think about things that don't relate to cold. And so it always struck us as an interesting model to study. And there are two routes through which we came to it, and those are somewhat different. One was I was involved in the study of internal thermal events that are natural. And my colleague Auto Music was involved in some of the animal work and the idea that there are certain processes that have been identified in animals that may come to play in how humans exert some kind of defense against cold. But cold actually for humans seems to be, like I said, one of those really foundational environmental stressors that we are constantly worried about. It's not so much that the heat, we never see the heat as an existential threat, though it is, extreme heat. or hyperthermia is also an existential threat. But if you look at the way in which we talk about cold in the general literature, it's really hypothermia that is seen as really a fundamental existential threat and something that we all fear.
Why do you think that is? Because there's lots of hot places on Earth, just like there's lots of cold places, right?
It's an interesting question, and I actually don't know why that is. It might be the case that the temperate zones that tend to get cold are more occupied than the areas like the desert, and so there are more people who are exposed to fluctuations in heat and cold than there are who live in extremely hot places or extremely cold places. And so maybe there is that sense that you feel that discomfort, and that's much more immediate.
So that makes sense. So you guys were interested in this cold response, but what got you really primed to think that it could be consciously controlled? Was there like a natural diversity among the way that people physiologically respond to cold? Or what got you really excited about this?
So we never sought to specifically understand that. But there are more than enough anecdotal cases of individuals in different parts of the globe with known cold or heat tolerance, well, particularly cold tolerance. And so, for example, I'm originally from India, and there are scores of examples that are talked about individuals who have renounced the world. This whole idea of renunciation is very big in Eastern cultures, and who have gone off to live in extremely hostile environments and managed to survive in very hostile environments. And a primary reason that has been generally advanced for why they're able to do that is because they're consciously involved in deliberating deeper philosophical problems of the world.
Like
Now,
contemplation.
Contemplation, that's right.
And so contemplation alone is sufficient to generate this ability?
So again, these are anecdotal examples. So obviously, I haven't studied them. I don't know if others have studied them. And I suspect that this is an incomplete explanation for why they're able to do what they're able to do.
But it's intriguing. It sort of piques the interest, sort of draws you into what could be going on with these individuals.
It is intriguing, and it could be a very extreme case of what we might call not minding things. So, for example, if any of us are exposed to cold, and while we are being exposed to cold, we are being asked to engage in some, and I'm talking about an experimental setting, we are asked to be engaged in some kind of deep cognitive activity, okay? Which, let's substitute that for contemplation. You can imagine that for some substantial period of time, you might be able to not mind the cold because you're actually the conscious aspects of your brain, which normally would be devoted to the process of interoception, that is, to be devoted to kind of monitoring how you're feeling internally. Those conscious aspects of the brain are actually focused on doing something that's much more immediate. And it's plausible to think that the resources that would go to interoception might actually be devoted to cognitive activity, or what we might generally call contemplation. And so you might be able to not mind the cold for some periods of time. So it's plausible, though again, I have no knowledge of this or no evidence of this, but it's very plausible that what these anecdotal cases we are talking about is just an extreme example of that. Go
ahead.
Where you can actually find a way to not mind the cold to a certain point, or at least where you are able to modify what physiologists call the thermoneutral zone of your body to take it to a different homeostatic baseline. And you're able to actually tolerate levels of exposure to cold that normal people might not be able to tolerate.
But are you still, at that point, experiencing some kind of physical change in the body? Because that's the gold standard, right?
That's an open question, and almost certainly physical changes are physical changes. and whether what you're doing through contemplation can modify what is happening at the level of receptors on your skin, that to me does not seem plausible. But what seems to be plausible is you're modifying how the signals that come from the receptors of on your skin that are responsive to cold, those signals as they travel upwards to your central nervous system, it's very plausible that contemplation is modifying those signals as they come
By
upwards.
sort of interfering with those relays or something like that.
Plausible. I mean, we're just talking. So
Sure.
this is not a scientific theory, but all of this sounds completely plausible.
Well,
But you have actually studied at least one individual that seems to be able to display some level of conscious control. Is that correct?
Correct. So Auto Music and I were interested in studying Wim Hof. And Wim is unusual in many different ways. He has, I think he's one of the most well-studied individuals with a very high tolerance for cold. Like I said, I suspect there are many others like him around the world, except that they're not necessarily accessible to scientists or to empirical study. But Wim is, because he's in the Netherlands, he has objectively set multiple records for cold tolerance. And so this isn't just somebody saying that he can tolerate the cold, but there's objective evidence for this. And it raises many, many interesting scientific or quasi-scientific questions about what is it that allows him to exert such unusual levels of tolerance. And so this became a starting point for our study. And Wim became, for us, a quote-unquote very valuable specimen, and I mean that in kind of a scientific way, a very valuable specimen that could be studied because of this unusual activity that he has. In the same way that people who have unusual copious amounts of working memory are of interest to people who study working memory, or people who don't ever forget an episode are of interest to people who study episodic memory, and so on.
I see. Now, Wim's pretty exceptional as far as these things go. It seems like there's some evidence that he can control his innate immune system through this same technique and maybe even teach it to other individuals. Is that true?
We have not been involved in those studies, but it appears that there are individuals in the Netherlands who have actually studied not only him, but volunteers who have been trained in the method that he uses, which is a combination of breathing, controlled cold exposure, and meditation. And they have actually studied anti-inflammatory responses in novice volunteers who went through I believe it was an 8 or a 12-week period of training. I don't remember the details. I was not involved in that work. But there's some evidence.
Does it surprise you that the innate immune system and the cold exposure are related in terms of
Not at all.
No.
No, not at all.
Why is that?
Because cold is a stressor, and we've known for long periods of time now, even though we have not sort of codified this knowledge, that low levels of stress are actually extremely important in evoking a response within any biological system. And this response, we know, actually is essential in defending in potentially higher levels of stress on that same dimension. And so to me, it's not surprising that you would find this kind of evidence, because the way in which we tend to think of neurobiological systems in the work that we do is that these are not modularized, that is, that these are not modules that are independent, but rather that within the neurobiology of the brain, things are highly, highly interactive. And whether we can understand or whether we can consciously experience those interactions is really not really the question, in as much as can we capture those interactions.
So it's all about response to stress. like the cold is stressful, the exposure to bacterial pieces is stressful. Can the human learn how to control those responses so they're not out of control and the human can function in these stressful environments?
I think that, so let's kind of pretend that we know what the word stress means, right? Because the word stress means different things to different people. But let's not get kind of bogged down in the precise definition of stress. But let's say stress along any dimension is something that is uncomfortable along that dimension. And so it appears that, yes, that defined that way, low levels of stress actually exert a highly ameliorative effect on the system because it provokes a response to the system. And in provoking and in managing that response, the system finds a way in which to cope with higher and higher levels of stress. This is kind of true if you kind of think of it on reflection, this is true about many things. This is kind of how athletes train, by subjecting their bodies to lower levels of stress. So once they're actually committed to higher levels of stress, they're able to respond, they're able to ramp up.
So it's like a hormesis effect almost?
I think that is what you have to think of it. That it is a bit like a hormesis effect.
Which is that a little bit of a bad thing can actually be very, very good.
And as long as that little bit is tuned to the individual, because what is a little for me might be a lot for you or vice versa. And as long as the system can evoke or can construct a response that overcomes that low level of stress, that I think is critical.
Well, this is something that's really, really interesting in your work in general, where it seems to be that the suggestion is that if you can train yourself to overcome the suffering when it's something that's very small, this has massive effects that reverberate through life in general.
I think I would agree with that. But again, I would say that what's so surprising? We do this every day in our daily lives. We try and control kind of the levels of discomfort, whether we do it consciously or not, whether we plan it or not. That's essentially what we do.
Of course, but I think that humans in general want to get away from discomfort. They want to get away from suffering. This seems to be a central thing on Earth right now, which is that to suffer, especially in the countries that are well off, is the goal of life, is to evade that suffering, is to make sure that you're comfortable as much as possible, whether it's with ideas or temperatures or you have a car that you drive places, you know?
And actually, this is a question that we grapple with. And so there are different shades to this question: scientific, philosophical, evolutionary. So if you take the last of those first, it's very plausible that this is a relatively recent evolutionary trend. One hesitates to talk about evolution because everything can be proven and everything can be disproven, right? When you're just talking about a concept in a nebulous way.
It's just a hypothetical story of what might have been the case.
Correct. But I think that this is probably no newer than maybe a few hundred years old.
Whoa.
The search for comfort.
I think so. I mean, or at least this idea that much of what we do must be principally driven by the need to find comfort. And again, it's our biology and our responses are constantly being modified by an environment that our biology is building. So that's kind of a conundrum that you have to think about. But with advances in time, technological advances, engineering advances, it's now plausible in certain cultures to live your life experiencing virtually no physiological discomfort. And if you think of what we know of human evolution, this is extremely recent. I mean, it's probably a nanosecond compared to the millions of years of human evolution that we have documented. So it's the question is how does this play out in the future? And does this tell us anything fundamental about human biology, or is this simply an epiphenomenon of how environmental changes? By environment, I don't mean just the environment, I mean kind of everything around us. How those changes are actually modifying, or how easy it is for human biology to be modified by the environment.
And how can the humans push back against the modifications that are happening without them noticing?
Correct, but some humans enjoy pushing back. Some humans really enjoy the discomfort. I mean,
Exactly.
I can give you a personal anecdote. I was perfectly happy never stepping out in the cold till we brought home our first pet, our dog Sage, about 15 months ago. And since the onset of the COVID-19 pandemic in March, when most of us have primarily been working from home or work habits have changed, I have walked with her between 3 to 5 miles every morning, come rain, cold, heat, or shine. And over that period of time, I have found that I actually look forward to going out in the cold. Today it was 10 degrees Fahrenheit when we walked outside.
Wow.
We walked for about an hour, 15 minutes. This would have been unthinkable for me before. Why? Because I simply allowed myself to settle into this pattern of comfort.
How does the dog react to it? Do you sense any hesitation when it's cold? Does she, you said her name was Sage?
Sage, yeah.
Does Sage seem to react the same way that you do to the cold?
She seems to be, so it's interesting, we're talking about interoception. Now, this is a species that has some level of consciousness and some level of sense of its internal states. But that's true of almost all mammalians, I think. And she is quite adept at, or seems to me, to be quite adept at understanding when it is too cold and when she wants to make her way back home versus when she wants to walk more and more, which is why I said we walk between 3 and 5 miles, because it's primarily governed by her pattern. And I think her pattern is highly responsive to how cold it is outside. So today we only walked about 3 miles in 10 degrees. Mm-hmm. If it was about 32 degrees, I would predict that we would go about 4.5, 5 miles.
So she's good at recognizing the cold as it happens, but it seems like there's something unique about humans where their physiology gears up just thinking about the cold, and they're starting to kind of ramp up and experience that before it happens almost. Does your dog experience that at all, or do you think it's unique to humans?
If we assume that, and it's difficult to, because soft tissue doesn't leave an evolutionary record, right? But if we assume that the forebrain and the frontal areas of the human cortex, which appear to be largely, not completely, but largely unique to Homo sapiens, are the seat from where consciousness, whatever that means, again, let's just assume that we kind of agree on what that means, emerges, then it would appear that humans would be unique.
Hold on, sorry, you mean like self-awareness, like conscious of yourself, or I'm sorry, you mean like awareness? Yeah, self-awareness.
Yes,
gotcha.
Yeah, I would say self-awareness, but not just self-awareness. I think consciousness, I would define it, if you ask me to put sort of the attributes of consciousness, self-awareness is one of it, but there are many other attributes, I think. Then you would assume that canines would probably not have that they wouldn't be able to, or they would not ruminate over, well, it looks like there's snow on the ground outside. I don't know if I'm going to really feel cold about it.
So it's like they're not abstracting their self into the future and imagining that they will become this cold dog later, kind of.
I mean, that's what I would surmise. Whether it's true or not, I don't really know. But I gave you sort of the logic of why I would surmise that.
Mm-hmm. And so when you go out into the cold, what do you experience as someone who studies this and understands the science of regulation and is, putting on your layers to go out into 10-degree weather.
Well, I'll tell you what, again, this is based on introspection, so I have no independent confirmation of what I'm telling you.
Mm-hmm.
But based on my insights and introspection, where about a year and a half ago, the act of layering up to go outside had like a negative affect associated with it for me. Now it's quite neutral. So in humans, and of course in all species, but I would say in humans, that there is and this is something that we have written about, there is not just the physiological component of the interoceptive state, but there is also the affective component. That is,
and that's the emotional component.
That's
exactly.
the motivation.
Emotion/motivation. And so with any interoceptive state, there is an affective component to it. And so, for example, warm baths are affectively very positive, but an ice bath is affectively very negative. And so for me, till I, through a habit, through ritual, through experience, began to modify my behavior, the act of kind of going out into the cold there was always a negative affect associated with it. Layering up, putting on your gloves, etc. But now actually it's quite neutral. And so I would say that is kind of a individual anecdote of how a specific type of practice kind of unpacks the layers of comfort that, what habituation gives you in the culture in which I live in.
It's almost therapeutic in some sense.
I think that the act of facing something unpleasant and actually overcoming that, and this gets back to what we were talking about as hormesis, I think that is therapeutic. And this is, again, widely known. It's not surprising. Like the highest level of arousal that you have before you take a bungee jump off of a bridge is before you actually jump. But what happens afterwards is exhilarating. It's therapeutic.
Well, it's not so much that it's surprising as it's amazing that you earth scientists are finding a way to document it so rigorously and actually bring out the details of what's physiologically occurring.
Because before this point, it seems like this was the domain of self-help gurus and an entire world of
Hearsay.
Exactly. I keep hearing people on Earth talking about manifesting. Mm-hmm. Have you ever heard that term?
No, I don't know. What does that mean?
It means that you imagine something, and by imagining it, you bring it into reality.
I see.
And so it's a motivational tool that people use, right?
Mm-hmm.
Where, you visualize success and then you make your way towards it. And this seems like a scientific approach to actually being able to explain how that could work, where you visualize your way to being warm and you breathe your way to being warm and you can tolerate an ice bath.
I mean, we are applying an empirical approach as we have been taught it in our careers, right? And so the basis of any scientific approach is this idea that you must be able to empirically manipulate a system, collect signals that result from that manipulation, and then functionally reconstruct what has happened in that system, right? So that's what we have been attempting to do. How accurate we are in our reconstruction of what's going on, how complete we are in our reconstruction of what's going on, those are open questions.
Why do you say that?
Because we don't know, for example, we don't know what are the limits. We have not tested all of the range of possibilities. For example, we don't know what the limits of conscious modulation or willful modulation of cold exposure are. Obviously, there are limits.
So, really quickly, I want to catch up on what exactly you have figured out as far as the science is concerned. Can we just real quickly recap like the mechanism of how this conscious control is happening? From what I understand, it has to do with the adrenal response and this sort of fight or flight suspension and talking to the brain through the vagus nerve. And
So let me speak very narrowly. Most specifically in our work, and this is a paper that we published in 2017 in the journal Neuroimage, or 2018, sorry. And maybe that's the paper that you're most familiar with.
yeah, it's a good one.
Yeah, what we demonstrated is that under certain conditions, cold exposure leads to a response in very deep areas in the brainstem. The medullary raphe, the periaqueductal gray, the dorsal raphe, these are areas that are not part of the conscious brain. These are areas that are involved in autonomous control.
Life support stuff.
Generally speaking. And these are areas that seem to be extremely engaged during cold exposure when we studied Wim Hof. And we compared the data that we collected in him to a cohort of quote-unquote healthy participants who, of course, were not familiar with the Wim Hof method, etc. Now, that is a finding that we published. Now, everything else is a speculation based on that finding.
I understand. So what is this pathway? What is the physiological pathway that you guys are uncovering?
So our speculation is that the areas that I mentioned appear to be involved, and this is from more careful physiological work that others have done, are very fundamentally involved in they're the central pathways that are involved in the modulation of the pain response. And so what appears to be happening is there appears to be some form of modulation. Again, I'm using the term modulation very generally. I'm just saying change or a change from baseline. And so there is some form of modulation that is taking place following cold exposure in these deep brain areas in individuals who are skilled in the Wim Hof method, which suggests that what the method is doing is, again, this is speculation, so I have to be absolutely clear about this.
Understood.
We can speculate that maybe the method is actually priming some of these pathways that are actually not part of the conscious brain. And so
down the spinal cord and outward.
Correct, on the path towards the spinal cord. And so again, this isn't kind of what we expect when we say that we are not minding something. So when we say we are not minding something, let's say that somebody puts a pain stimulus on my hand and they start ratcheting up the pressure, and I can continue to not mind. What that really means is that my conscious brain is telling me, don't worry about the pain for now.
Stop paying attention.
Yeah, stop paying attention. That's not a process that we associate with the medullary raphe or the periaqueductal gray or areas in the brainstem. That's a process that we associate with areas that are evolutionary newer, like the dorsolateral prefrontal cortex or the anterior cingulate cortex, and so on.
So you're saying the signal is being broken up before it even becomes able to be processed by the higher cortical structures.
It must be coming from the body then, right? As opposed to coming from the cortex.
Well, what we are saying is that our findings lend themselves to the speculation that some of these methods can serve to modify the responses of regions in the brain that are not thought to be part of the conscious brain. You see? And so this is a speculation. Now, what the neurochemical implications of it are, whether this relates to the release of endorphins or cannabinoids, etc., these are all open questions. And the methods that we used don't lend themselves to answering those questions.
I see.
So if I had to use an analogy, I would say that you're sort of standing outside a room with the door closed, and you're trying to figure out what's going on inside the room. And you crack the door open a little bit, But of course, through that open crack, you only see a sliver inside the room.
And
But
this is your technique that allows you to see through that sliver.
it's the technique and the way in which we constructed the experiments and so on. But of course, there's just a lot more that really has to be understood. But then that's generally true of science anyway. I think that a goal of science is to begin to place questions on an interesting trajectory, along which then you can begin to answer them. So a goal of any single study is not to answer everything about the phenomenon that you're trying to understand. It's to, again, to kind of orient a field towards in certain direction, which you hope is well motivated.
And what do you think is the path that you have set yourself on in this case? Do you have a sense?
Actually, there are many paths. And so, for example, what is it that defines these interactions between and again, I'm just speaking generally, the conscious brain and the subconscious/unconscious brain? How do those play out in the context of perturbations in internal body states, particularly thermal regulation? How much interaction is there in both the ascending direction, that is from the periphery upwards, and the descending direction from the center to the periphery? What are the limits of that? What kinds of endowments can training give individuals in this? Does training modify fundamental aspects of the neurobiology of many of these systems? So these are all questions that kind of readily come to mind, and it would take an enormous amount of investment to try and answer all of them. But this is certainly a set of questions that we are trying to work our ways through conceptually.
And so I suppose my question is this. If there's no change in the activity in the cortex between someone who's able to control their body temperature and someone who's not, if all of the changes are in these deep brain areas, then doesn't that suggest that the signal is coming from the periphery rather than from the cortex?
Not necessarily, because what the endowment that allows that modulation is presumably arrived at consciously. It's arrived at through the conscious application of a set of practices that are potentially modifying the functional neurobiological response. From our study, it appears to be that the primary site at which that modulation is happening is deep within the primitive structures of the brain.
So the idea is that the cortex is affecting downward upon the hindbrain?
So again, when we say that, we in our work did not find evidence of the cortex actually doing that.
I see, I understand.
But does that have to do with the metaphor of the room and the sliver? Because if I remember correctly, you're looking at the brain in the fMRI scanner after the method has been completed. So you're looking at the aftermath of the breathing technique, not the inception and
that's correct. So this
execution of it.
So essentially, the system has been primed to defend against cold. It is not defending against cold while these techniques are taking place. But actually, that's a more interesting question, because after all, if it's going to take you an enormous amount of effort to defend against the cold each time, well, it's not going to be worth it. What you want to know is whether the practice provides you with the endowment to defend against cold. And so that for me is actually how the practice modifies your functional neurobiology is the more interesting question than what is happening when you're actually engaging in a practice.
So the practice primes the system. Can we talk a little bit about what the practice is doing? Because it seems like I don't know. Obviously, you're not studying the HPA axis, but the adrenal glands get involved at some point.
And there's three parts of the practice, right? So it's breathing, visualization, and cold exposure.
And I've tried this before up here on the spaceship, and it kind of feels like you're going to die when you do this breath hold business. It's very difficult, actually. And I totally understand what the word stress means every time I try it.
And so I think that, so again, it's difficult for us to know exactly what each component of what is being done is contributing to the overall effect. But generally speaking, I think that this is a marriage of stressors in different domains. And these are foundational stressors that act on extremely primitive and foundational mechanisms in the mammalian system. Respiration and controlled hypocapnia and cold defense. And it is married to, and so these are kind of stressors that come from below. And to that it marries sort of this meditation technique of visualization and mindfulness. And so it's extremely plausible that this combination becomes extremely potent. That is, you have a level of hormetic stress that is coming through different pathways, and that is married to this top-down mediation that is designed, that is not, as far as I understand, is not explicitly designed, but serves this purpose of kind of regulating a conscious response to low levels or lower levels of stress that would be extremely harmful. And so I think that this is a cycle that is, again, this is plausible. We don't have ironclad evidence for this, but the repeated practice of this engages in a very high level of plastic modification of ascending and descending pathways in the human brain. Again, it's not surprising because almost everything that we do through life, or it would not be surprising, because everything that we do through life is kind of either inadvertently or consciously designed to modify our biology. Whenever you learn a new motor skill, that's exactly what you're doing. Whenever you learn some new technique, that's what you're doing.
And why do you think that the three methods have to be used together, the three steps of the technique?
Because I think, as I speculated, and we've speculated on this in publications, it's that marriage between, so imagine that you're simply exposed to cold, okay? And so let's say that this whole idea of you being exposed to something over and over and over again familiarizes you with it, but actually has, and so through that familiarity, you develop some level of resistance. But imagine that from married to that exposure, you also have a meditative effect that is designed to kind of provide you sort of a top-down modulation of these perturbations, or modulation, or a top-down, what's the word that I'm looking for? A contemplation of these changes that are taking place in your physiology.
Like a way to integrate all of this signal in a positive way somehow.
Correct. That is this idea that, you know, you're being made to feel cold, but while you're being made to feel cold, in the aftermath of it, you're being asked to meditate your way out of this feeling.
And you have a technique for that. That's what's pretty cool. Humans love to have techniques, right?
Exactly. And so again, this is pure speculation, but you can imagine that it's this marriage between a stressor and a top-down method of control, aspects of which we exercise in our daily lives in innumerable ways.
So it's like pairing a stressor with a solution regularly kind of trains the human that I can handle this. And it really turns out they can.
But again, this isn't all that surprising. So these principles are at play in many other areas. So, for example, exposure therapy is used very frequently in anxiety disorders. What is exposure therapy? It's the same basic principle. If you look at immunology, this is a principle at a much lower level within our biology. By lower, I mean not conscious. But the idea is that you actually evoke a response to a very low level of an agent. And that actually ends up priming the system to defend against more potent levels of that agent. So is it surprising when you think of it that way? It's not surprising. I think what is kind of interesting is that people now are trying to codify or trying to kind of organize our knowledge in this area where it previously wasn't really studied.
And they're trying to, it seems like you all are trying to understand the structures that are involved too.
That's correct, because we have some methods that we can use now. The methods are extremely imperfect, but there are some methods that we can use. You can marry those methods to well thought out psychological experiments or experiments. We have hundreds of years of sort of training in empirical science that you can bring to bear. And so you can begin to try and reconstruct what is happening through controlled experimentation, acquisition of data, analysis, and so on.
And do you think that this analysis will ultimately benefit the practitioners of these methods? Or how do you imagine that it could be instrumentalized? Not that it has to be, but curious.
So I think a role for science is in demonstrating that something is real, not because we or practitioners believe something to be real, but because you have independent confirmation that it actually is exerting some kind of a change. And I think that the problem in this field is that it is kind of populated by charlatanism, right?
Wow.
So you have sort of self-help gurus who say, if you do this, things are going to get better. And there is this kind of effect where if you have an authority figure telling you that if you do something, you will get better, you do kind of feel better. But the question is, does that actually change anything apart from you feeling better? Which I'm not discounting the fact that the sense of feeling better is important. But the issue is whether the subjective sense of feeling is linked to any other objective changes that can be identified.
Well, if we can link this back to colds, then there's a difference between feeling warm and actually seeing that your core body temperature doesn't change.
Correct. Exactly. So those are two different things. And as you know, humans are extremely sensitive to the power of suggestion. This is a power that has actually been misused through the centuries by charlatans. And this actually becomes the basis of cults and different types of movements and so on. And so it becomes vital for empirical science to demonstrate that just because somebody says something is happening doesn't mean that that is happening. That is, you have to have a system in place that allows you to demonstrate with some acceptable level of doubt, but demonstrate that these changes actually are happening. And so that's kind of where we see what we're doing as kind of fitting in.
Are you concerned that you might accidentally legitimize the work of cults?
No, I don't believe that they are sensitive to. I don't think cults are particularly sensitive to science or empirical inquiry. Those are primarily driven, I think, by affective responses within individuals.
So there's a difference between the sort of short-term affective response and the long-term physiological changes.
Yes, I think so. Yeah.
Interesting. So, but then this brings us to the question of placebo, right? Because this seems like the interface between the affect and the physiological change.
Correct. And in fact, we haven't studied placebo ourselves, but many people have and attempted very, very well-motivated studies of the placebo effect. And if you talk to somebody in the pharmaceutical industry, they will say it's a real problem because people feel good when they're told that they're taking a pill that might make them feel good. And why is that? And so that's another reason why objective or quote unquote objective or reliable data allows you to kind of ground what a placebo effect might be or what a top-down effect might be, that what are the correlates of when somebody says that they're feeling better, what are the correlates of that?
It's really interesting. So it's like you guys are policing the objective appearance. Like what are we seeing? What is the phenomenon itself? It's like a lot of times it seems like the phenomena itself isn't understood, or if it isn't even apparent, like some people are just claiming it to be the case, then you don't really have anything to study the cause of because you don't know what you're looking at. But it seems like your work has a lot to do with just describing very, very carefully in physiological detail what's happening during these processes.
That's our attempt. And again, the implications are the speculations, those are all separate from the very narrow conception of what it is that we are finding. So we have to keep those things as quite separate. That is why we tend to be somewhat careful in speculating about the implications of the work.
The best kind of scientist.
Yeah, I like that. So you're very carefully collecting all this information about what's happening, and then you have these sort of hypotheses, and you can have these little theories on the side or whatever, speculations, but ultimately you're doing a great service by just inscribing the boundaries of what is known.
Well, thank you for saying that. We don't see it as a service. Unfortunately, it's a bit self-indulgent because if you're a scientist and you're fortunate, you get to study what it is that you find interesting. And so, a positive way to describe it is the way you described it. A negative way to describe it is the way I described it.
Well, even if you find it curious, I'm sure a lot of other humans do too. So you're serving them whether you like it or not.
That's good. But I mean, there is a fundamental problem in this kind of, it's kind of interesting if you really think of it. When people talk of new age approaches, they're actually old age approaches. That is, coming from the East, that's where I grew up. You're constantly exposed to ideas which in that culture don't seem particularly peculiar because they have been codified in that culture through centuries. And so there's a certain familiarity.
Do you have examples?
Well, like when we started talking about individuals who have extreme resistance to cold, who renounce the world, and this isn't something that you find particularly peculiar because you hear of it all the time. And you kind of think of it as relatively plausible, or this whole idea of meditation. Now, it just so happened that the emergence of these ideas did not intersect with the more recent approaches in the West about the empirical method. And so these ideas just became kind of accepted and are practiced by millions of people, but were not really necessarily codified or studied by science.
And what's really interesting is it's not just an empirical method in the West, it's also this very molecular, gear-oriented, fix this one gear and it'll change this effect. And do you feel like this is giving some sort of, how do I want to say, it's
like an instrumental?
Yeah, is it sort of bringing what was known in the past and giving it some credibility? Do you see it as sort of rescuing the past in some sense? Or exonerating it from some shame that it was given by the West at some point?
Plausibly, it serves that purpose. Though again, I never particularly bought into this idea that some of these life organization techniques are charlatanism. And I also don't buy into this, the way that they're co-opted by New Age gurus, that they solve everything. These are just life management techniques. I mean, I see them as fitting within this idea of you should exercise every day because it's helpful. You should eat healthy because it's helpful. I mean, it's kind of within that the same spectrum, you see.
I guess the question is less about the life organizational techniques, as far as I understand it, and more about, you grow up hearing about these people in the mountains that can expose themselves to colds, and then all of a sudden, as an adult, you go into the world, and you're like, well, is there something about that? Can we actually put that in a scanner and find it?
And can I use that?
And can I use the Western methods to explore something that is anecdotal?
Correct. And I think so. In that sense, I think that the careful application of the scientific way, as long as that there is constrained speculation after you find the results, becomes extremely useful.
Constrained speculation is
It's
very,
almost
very
like
important.
you got to put on a different costume to be the speculator or the theory builder. It's like you have to step outside of being the measurer.
That actually becomes the challenge in science. So results don't, and I'm speaking somewhat crudely here, results don't sell, it's the speculation that sells.
Oh, yeah.
You see, and so the problem is where science, and let's say we just kind of understand what science means, but where science gets into trouble is where the speculation is kind of unhitched from the results.
It goes too far.
It goes too far if it just is, it places too heavy a burden on the results than the results can bear. And so I try, you probably notice, I try and be very careful when I speak, and I say that this is speculation. This is about as far as we go. This is not what we studied. This is what we studied. So I try and be very careful when I speak about those things, because it's very easy to convey impressions that are simply not supported by the data.
Well, this is the fascinating thing about earth science, or science on Earth right now, where so much of it is couched in these fantastical terms of belief and expertise and speculation. And there's a crisis.
People fall in love with these speculations, I think. And when people become enamored, then it's all becomes a dogma very quickly.
Yeah, there's the sense on Earth right now that humans are suffering from their inability to limit their speculation on the data. And it creates a cascading crisis.
Because people believe them. They're like, wow, you know how this is supposed to be. And then if they turn out to be mistaken in some way, it's like the whole floor falls out from under the system.
See, I think that there's just a sort of a quantum evolution in the human species that is taking place in front of our eyes now. That is, information now is becoming, so the way in which in some cultures food scarcity was solved by the optimization of farming, the optimization of the dissemination of resources, etc. That has now been the dissemination of information and data is now playing that role. And so now we, in a very short period of time, have gone from not being able to efficiently disseminate information. So the only way you would disseminate information was physically, right? Like take publishing in journals. 30 years ago, the only way you would read something in a journal is if once the journal arrived by post.
Yeah.
Now I can't even remember the last time I actually held a journal in my hand, right? So
and even correspondence itself as letter writing in philosophy and science is pretty modern, right? I mean,
exactly.
People were probably waiting for someone to come from another village and tell them a story otherwise.
Exactly. So now, just as we went from sort of I'm exaggerating, but I don't mean literal starvation, but the distribution of food went from starvation to not gluttony, but self-sufficiency to sort of some optimal way in which most people in the cultures that in many cultures in the world now have access to food. Where we are now with information is we are in sort of an age of gluttony. And imagine if you were force-fed, literally force-fed food till the point that you burst. This is where we are now with information. And this actually creates opportunities, but it also creates really an enormous level of vulnerabilities. And so it would be quite easy for me, for example, to take a very small study that we did, and as I said, sell the speculation of that study. Because that's what people are going to be interested in, not kind of the details of what we found, or we found some brain responses in some obscure region of the brain that nobody can even think about. It's easy now to leverage that small finding and then broadcast that information, but in a way that is actually not credible anymore. And so people are now gluttons for information, but it isn't really necessarily bringing more insight. And
so people are really incentivized to, especially scientists seem really incentivized to defect on the whole information ecology. What do you think the solution to that is?
I think about that a lot, and none of the solutions are palatable. So
what are the options?
Oh no.
I don't have a response to that. I wish I did. I mean, some of the most obvious solutions are sort of the constriction, right? Constricting the flow of information. But that's not optimal. Who decides who to constrict the flow, right? So, I mean, that just is obviously not optimal.
What about bottom-up skills? Is it possible for humans to learn to tend to their own information ecology in a healthy way?
I'm afraid...
Is the motivation there?
I'm a bit pessimistic about that, because I think that, as one of you said, it's now possible to incentivize the dissemination of information. And whenever that is incentivized, there is no disincentive to actually be careful about it. If you can incentivize clicking on a web page, what incentive is there for people to reduce the number of clicks that somebody can make on a web page?
Well, it has to be a personal incentive, right? The person who is looking at the website has to say, I'm not going to click on that. I know what they're doing to me.
Exactly. And so these solutions would need to be implemented by every individual. But I'm a little bit pessimistic that, and this will sound elitist, but it's not elitist. I'm a bit pessimistic that individuals are able to do that, because in each one of us, there is a balance between, and again, I'm speaking loosely here. It's not a scientific theory, but I think we would agree with this. There's kind of a balance between our cognitive state and our affective state. And I think it's easier and it is more primal to give in to our affective states. And I think that's why it's a challenge. And so I think, getting back to the point that we were discussing, I think it's the nature in which the world is becoming more and more organized. It's becoming easier and easier for scientists to do a little bit of something which has rigor in terms of what it is, but then to amplify that through the phone, through the medium that is the internet and media, which now means almost anything. And then to sort of sell that in a way that it cannot be sold. And remember, this is information, so this is actually not something like a physical good. So for example, if I'm sold a shoe, that isn't a particularly good shoe, I know that.
Well, yeah, it falls apart, right?
Exactly. But what's the problem with information? If I sell information, How does the consumer know whether it's particularly good information or not? Frequently, it's important that the information elicits a certain affective sense in the consumer of that information.
Especially the more abstract and distant that piece of information becomes, right? When you're talking about pieces of the brain, that's already starting to get kind of distant. If you're talking about
Exactly.
bacteria, you're one step farther. If you're talking about galaxies, you're even farther.
Exactly.
Well, the humans have ways of dealing with things they can't see in medicine, right? Like they have the FDA that verifies whether a drug will kill you or not. So they have legal drugs and illegal drugs that are kind of do at your own risk.
But that's such a concrete measure, right?
Correct.
Like Dr.
Correct.
Diwadkar said, it's like you have a pill that has a measure. Will it kill you or not?
Mm-hmm.
But
So
with a piece of information. Oh, go ahead.
Exactly. Yeah. So, like what you were going to say, information is not like that. So the way in which the information economy now is being driven, and I'm not saying that this is the only way in which it is being driven, but a way in which it is being driven is it is primarily being driven to modulate affective responses in individuals. And the standard for what is true and what is not true. See, in science, to understand whether something is true or not true, it takes an enormous amount of time. In the rapidly evolving media age, these decisions are made on the matter of minutes. You see, and it's not possible to make these deliberations on the matter of minutes. And so it makes sense that if individuals are trying to sell information, they are going to go down the path of least resistance. And what is the path of least resistance in humans? It's to grab humans affectively. It's
By the brainstem.
Exactly, by their affective response.
Grab them by the brainstem.
Yeah, so that's a challenge. And so I think we got off on talking about this from I think the perspective of what is the science of what we are doing mean. Now, and I think I was trying to say that what it means is essentially always going to be in the eye or the brain of the beholder. And we have a certain conception of what it means, but I don't think that conception is sort of interesting enough for the brains of the beholder. So I think people will take it in different ways.
They want it to be bigger than it is so
Correct.
that they can build a more complete model. Well, that's one of the frustrating things about science, right? Is that each finding, each result, each paper is such a tiny step forward, such a tiny addition.
And more now. Those steps are tiny and tinier and tinier now, when an enormous amount of science now is kind of the generation of results without any insight. So those are two different things.
Do you think that's because scientists are very scared of speculating and offering these knowledge directives?
Or maybe they don't have time.
I think now you have to get into kind of this idea of how this whole notion of incentivization, sort of how the system of science works. And again, there's not one way in which it works, but a way in which it does work for the most part is people in science are incentivized to publish. And they are incentivized to publish positive results.
And publish first.
And publish first, and publish quickly, and publish a lot. And so, in a sense, this is the challenge of performing, this is the challenge of doing science in a world where everything is becoming more and more incentivized. Whether it's a monetary incentive, whether it's a academic incentive, you're more and more being trained to work towards doing or gaining something. And so what you're doing becomes the currency, I'm speaking loosely, but becomes the currency by which you gain something that you're being incentivized to gain. You see?
Well, the people with the coolest theories and the coolest speculation will rise to the top
wackiest
of
and wildest and most amazing.
most surprising.
Well, so in a world before sort of this massive development of media, the way in which this all would play out is it would take months or years for it to play out. And it still plays out in some aspects of academia, like in pure mathematics, that I know a little bit about. You can't really sell pure mathematics to the public.
Well, there's that
just
one
no-
guy who tries, who's like, everything is math, right? Max Tegmark.
No, I don't know who that is.
He has a theory that we live in a computer simulation, and so he shows up on all the big programs and
I
telling
see, I
everybody
see.
about theoretical math.
I see.
But again, it's the most extreme speculative version of it. The only way
Exactly.
that you can sell mathematics is by
Correct.
saying you live in a computer simulation.
Correct, but the point is that if you're a academic in pure math, and I don't know if the individual you mentioned is a professor or not.
Yep,
Okay,
somewhere in
But-
Europe.
okay, but generally speaking, that is not kind of how you would gain what is called notoriety. Because pure math unfolds at a time scale that is very slow. It's very detailed. It's very deep. There's a lot of deep thought. There's a lot of theorem proving that is involved and so on. But the field that I inhabit is a bit different. The field that I inhabit, it's much easier to actually generate results, to create results. And then those results they can become currency that you use to gain notoriety. Because now you have the sheen of being a scientist, and people kind of are trained to accept that what a scientist said must come from a place that is very well thought out. Well, the way in which the experiment was done was very well thought out, but everything else that's tacked onto it later might not be very well thought out.
It's certainly more hypothetical. It rests on a story that you're pasting over top of
That's right.
all of these
That's
pieces
right.
of evidence.
Yeah.
And it's so interesting that a big spread of evidence could be used to tell so many different stories.
Correct. And if you think of, again, I'm not saying that this is true in all cases, but it's easy to imagine how science is now becoming integrated with kind of an entertainment industry of a kind. You see? So the way in which news now, certainly in some parts of the world, has become intertwined with the entertainment industry. Like when I was growing up, the idea of a 24-hour news channel was absurd. There isn't that much news that's interesting, right? But now, because you can the system incentivizes the creation of news, right? You have 24-hour news channels. And so now news is entertainment.
Yeah.
And so the danger is that science is or could be moving in the same direction as news, where it now becomes diluted to the point where the activity which is conducted or can be conducted, hopefully is conducted very carefully, results in outputs that are speculated upon in extremely irresponsible ways or extremely loose ways. And that's not helpful.
And it doesn't help your sworn duty to protect the pure description of the phenomenon so that it's really well known, because all of a sudden you have individuals incentivized to maybe make what they're curious about curious and appealing to everybody.
That's correct.
And that could result in paying attention to certain details and not others, and just generally not helping to police the objective understanding of what is actually happening.
Exactly. So, I mean, these are challenges. I think that these will become more and more acute. And so this idea of demystifying science, I think, is extremely important.
Yeah.
Because I think that people need to understand that what scientists do and what they say they're not necessarily coming from the same place. They might do things very carefully, but they might talk about what they have done and what it means in very liberal ways.
Well, that's a fascinating dichotomy, right? So you have this person, the scientist, that actually embodies two different characters. One character is the careful engineer, the one that considers the variables, the one that puts together the experiment, the one that
Collects the data. Controls the experiment.
And then you have the other person, the storyteller. And the storyteller is almost like this complete inverse of the engineer.
Or could be.
Or it could be, in the worst case scenario, right? I mean, in the worst case scenario, you
Is
have
it
a bad
bad?
engineer and a bad storyteller together, which is chaos. But in what I've read about Earth, it seems like the storytelling aspect of science isn't really taught very well to students. Do you think that that's the case?
It's an interesting question. So if I think back, I believe that I kind of worked on sort of the narratives myself. Well, let's speak concretely. Let's think in terms of a typical scientific paper in my field. Okay, it has an introduction where you pose the question. It has a method section which tells you how you actually implemented trying to address the question in detail, with enough details that is in theory replicable by somebody else reading it. You have a results section, which should be about as cut and dry as possible. And then you have the discussion section, which kind of ties everything together. Now, buried in that discussion section is kind of where people speculate about what the results are. And then even above and beyond that is when people who have done all of this and get their paper published now actually speak to the quote-unquote general public, right? And you might say that this is kind of what I'm trying to do here, right? The assumption is that people who listen to what you have to say or what people that you talk to have to say are not trained in science. And so they're the general public. And so where the problem comes typically is the gap between the results section of a paper and the discussion section of the paper. Because if a paper simply stopped at the results section, well, then it's probably not that interesting. And so scientists are they are asked to think about what the more general meaning of those results are. And we went through that exercise a little while ago when you asked me sort of what the meaning of the results of our paper are. And I said that, this is what we narrowly found. And then you can speculate a little bit beyond that. But just to be clear, we didn't study that.
And it helps you to sort of figure out where to go next, it seems like.
Correct, exactly. And so that's actually the problem that a lot of people in science are in the fields that I work in are faced with, that they have to exercise a degree of responsibility in extrapolating from the results to what those results mean. And if they get a set of, and so they finalize the paper, they submit it for publication, and the hope is that they get a set of reviewers who are very careful in reviewing the paper, who are very careful in drawing the line between the results and the discussion and ensuring that that line is not really too long. You see, that it's close enough. It's close enough to be meaningful, but it's far enough to be interesting. Right?
And so they're not overstating beyond what their results could say, but they are pushing the frontier or pushing the sort of
imagining possibilities.
The bow shock of knowledge. Yeah, exactly.
And my feeling is, and I might be wrong about this, but my feeling is that it is a little bit difficult to train trainees in how to write the discussion section of a paper. And this is something that people end up learning on their own. And this I base on my experiences both as a trainee from many years ago, but in some ways I'm still a trainee because everyone learns as they go along, but also a mentor where I'm trying to help students to organize the set of results that they have come up with into a discussion section of a paper. And this is the real challenge. And I think a challenge is that what I see more and more is that not enough scientists bring philosophy into their work. And this is a real problem because science is, you remember, science used to be called natural philosophy before it was called science.
Yeah.
And there's a good reason why it was called natural philosophy, because it was till kind of it became really dominated by this empirical approach. There was a balance between empiricism and kind of considering the philosophical implications of what it is that you have set out to do and what it is that you have found. And so that balance now has shifted, I think, more in the direction, as one of you said, more in sort of an engineering direction, kind of the generation of results.
And the instrumentalization of them towards, honestly, towards markets mostly right now, it seems like.
Correct. And in the field that I'm in now, it is actually quite easy to generate results. It really is. It's not difficult to generate results. The problem is that a lot of these studies are not infused with philosophy. And this I think, is kind of it's a challenge.
And by philosophy, you kind of mean ethics and ecology and how the findings relate to the world at large and society and the future of the civilization.
And those are some of the things that I mean, but also kind of is this a question that is a meaningful question to ask? So the famous philosopher of science, Thomas Kuhn, there's a quote attributed to him, which goes something to the effect of, the answers you get will depend upon the questions that you ask. And I completely believe that, because not all questions in the field that I work in are meaningful questions. It's possible to actually ask them and come up with results, but it doesn't mean that what you have done is a meaningful enterprise.
Do you think that there are first principles for being able to ask meaningful questions? Is there some template?
What is meaning?
Yeah, well.
Do you mean...
So now, so I think, so I thought about this a lot, and unfortunately I'm convinced that there are first principles. I have not found a way to codify them for myself. People have attempted in the recent past, people who talk about the philosophy of science, they have attempted that. Philosophers like Wittgenstein attempted that. I personally don't have a set of answers that I can codify for myself.
And so what is a meaningful question? Is it one that delivers insight?
Usable? Something beyond markets, perhaps? Not that markets aren't meaningful to starvation.
So that's, I think that it's not possible to come up with a simple answer to that, because the answer will depend on the field of inquiry. So the field of inquiry that I'm in, I can clearly say what questions are not meaningful.
I see.
Yet another functional magnetic resonance imaging study that looks at a certain phenomenon in a certain psychiatric condition. That's not meaningful because it tells us nothing. These phenomenon have been identified superficially. Now, what is more meaningful is to understand what more fundamentally they might mean. You see? So I think that it's easy for me to identify what is not meaningful than to articulate what is meaningful. But that's always generally true.
You mean like sort of how the pathology ties into the civilization or into the society or the individual's life or something like that?
Or why does the pathology happen?
Or what is the basis of the pathology, or what is the mechanism that gives rise to the pathology?
So mechanism offers meaning in science. That seems substantial.
I think that this, again, when you speak in English, it's easy to agree that the search for mechanisms is actually meaningful. When you start to implement that search in methods, that's where frequently problems occur, because people frequently intuit mechanisms from their data where it is not possible, in my opinion, to intuit mechanisms
So
from the
they
data that they have.
so they're overstating certainty. So
Correct.
meaningful work cannot overstate certainty then.
That's in my opinion, that's correct. I would agree with that.
So, do
Okay.
you have any ideas for how to incentivize this more meaningful work in your industry?
We expect that you've solved all of these problems.
Well, I wish I had. Um, it's a really good question. I I don't have good answers to that really. Um, so the idea of, you probably know what tenure is, right, in academic systems. So the
Well,
idea,
a lifetime appointment, right?
yeah. So a idea of tenure was to actually not the only idea, but a idea underlying tenure was that it solves this problem. That is, if somebody is tenured, they are no longer subject to quote unquote market forces in academia, and that they can kind of study whatever it is that they want. And I kind of agree with that. And so some of the work that my colleagues and I have done, I think we have been able to do because we do enjoy some of the benefits of tenure. And we can study things even though we don't kind of, it doesn't result in any sort of, some of the work that I do is difficult to get quote unquote funded.
It's not surprising enough or something, or it's not sensational enough.
Or it's a little bit on the edge of the envelope that a group of reviewers would find really not fundable. You see? And
Can
so,
you give an example?
like the work on thermal regulation that we do is, it's still seen at kind of that intersection between. Let me give you a concrete example. So we were actually interested in studying this idea of thermal regulatory processing in patients with schizophrenia. Now, it turns out that patients with psychiatric conditions, they seem to frequently be in a altered state of homeostasis. Okay, they don't feel
Physiologically.
well, psychologically they feel that way. And so the question is whether their defense against many of these mechanisms is altered. And so the idea is that if you can study a fundamental system like altered thermal regulation. So psychiatric conditions are seen as conditions of the forebrain, right? Of the prefrontal cortex, of the amygdala. They're not seen as conditions of more primitive systems, like the medullary raphe or the dorsal raphe or the periaqueductal gray and so on. And so we thought with good reason that a change in focus would be interesting because it might allow us to shed light on alterations in biological pathways that are actually typically not under the purview of study in psychiatric illness. And
So
again,
basically, to look at the question from a different perspective. People have
correct.
been looking at it from the perspective of the upper areas of the cortex. The limbic
Exactly.
system is the one that is generally thought to be dysregulated in psychiatric illness.
The limbic system, but also the prefrontal cortex, the anterior cingulate, these are regions that are conventionally associated with illnesses like schizophrenia, mood disorders, anxiety, et cetera, et cetera.
And so funders are more interested in supporting these more traditional ways of looking at these disorders?
Well, so I'm what I say sounds conspiratorial, but it's not. It is that when you submit a proposal, if its content is kind of really too far outside the conventional areas that reviewers are kind of expect to see, it the effect can be one of two things. One is if you get a kind of a group of reviewers who are very sensitive and very positive about meaningful novelty, they might like it. But on the other hand, you get reviewers who tend to be very punitive towards something that is kind of really out there. Then it becomes very unsuccessful.
And you think that that's because they are suspicious of a change in paradigm, or there's some kind of
safety, risk versus reward thing?
Or just a preference for the old model? Do they have a dog in the fight?
Anything that I would say would be just speculation without
Sure.
information. So I really would hesitate to speculate.
Of course.
But the point is that getting back to this idea, I think we're talking about tenure. So tenure does allow Otto and I to do some of this work, even though it is somewhat unfunded, okay, that we don't have support for it. But generally speaking, this idea of tenure as being a panacea to the question that it allows individuals to study things that in the absence of incentive, that is kind of going away because more and more incentives get introduced on a regular basis in academia, like the need to get grants, the need to raise support, the need to publish lots of stuff, which you might not necessarily be able to publish if you're on the edge of something.
And competition for those tenure slots is just going through the roof, from what I understand.
Tenure slots are expensive, which means that there are fewer and fewer tenure slots, and so on. So
we need a new method.
I don't know what the answer is. I really don't, unfortunately, and I wish I did. And possibly everyone will have to work out the answer for themselves. So everyone may have to decide whether the speculations that they bring up in the discussion section of their papers is responsible or irresponsible. Maybe everyone has to tune it for themselves, and you kind of let, I hesitate to say it this way, but you let market forces decide whether something is meaningful or not. So the more people that view something, the more meaningful it is. I think that that's an unsatisfactory way to think of something.
Well, it's unsatisfactory because a lot of the distribution is centralized still, and it's unclear, at least on Earth, to what extent the best products would rise to the top, or how much that can be controlled by the market forces that are already powerful.
Yeah.
My question is about changing who does the science, right? So we have this two-part process, the engineering phase and the storytelling phase. It seems like as long as there was access to all of the results of the engineering phase, people who weren't necessarily getting funding for that engineering phase, because that's what's really expensive, right? It's the materials and the equipment and the space and everything else. So what if there was people who were able to look at the results of the engineering phase and they didn't actually do any of the engineering themselves? They just looked across all
And to be
of...
clear, you mean this very hyper-descriptive, nuanced articulation of the phenomenon, which you have to engineer through these experiments. I think that's why Quinn's saying it's an engineering phase.
So if I understand what you're saying, let me give an answer, and maybe that's, or maybe my perspective, and maybe you would agree that I interpreted your question correctly. So there are now initiatives in my field towards open data. So the typical model would be that you collect the data and then you keep it. But now more and more national funding agencies require that you deposit the data in open repositories that can be used by anybody who wants to use the data. Now, there are, on the face of it, there are huge pluses to this because it democratizes the access to data. So it gives the data to more and more people who may not necessarily have the skills or the resources to have conducted the experiment and to have kind of collected the data, but they have the resources to analyze the data. So in a sense, it's valuable. But there are also other problems or some challenges associated with that. One is that the competition for resources to collect the data is still competitive. You see, And so those people who collect the data still have to go through this runaround where they have to write the proposals, get them reviewed.
Convince someone that it's worth collecting in the first place.
Exactly. And so it is still a relatively inequitable distribution of the costs and the benefits. So the costs are loaded onto sets of individuals who have to do the work to get the funds to collect the data. The benefits frequently accrue to people who don't actually have to go through doing that. And so, but nevertheless, some of these open data, open science incentives are valuable because it does mean that in principle, it means that the access to information or to access to the source of information, because in my field, information is frequently the results of what you do. But the access to the source is democratized.
I love that, but do you think individuals will actually have time to go in and dissect that when they're busy with their own projects, or is there a way to actually create a role?
Time will tell. So it's now plausible that individuals at institutions who those institutions did not evolve to be quote unquote tier 1 research universities. That is, they don't have a lot of infrastructure, right? And so they couldn't really engage in a lot of research activity. It's now plausible, and time will tell, that these institutions now fit better within this uncontrolled research enterprise because they would have the resources to do data science, because doing data science may not be as resource intensive as actually collecting some of the data. You see? So there may be longer term positives that emerge from this. Time will tell.
Yeah, it definitely played out like that on our planet. So we've taken a lot of your time. I was hoping to ask you one last question, which I kind of ask everybody, which is, what do you think is the biggest threat to your species in the next chunk of time?
Just to close out the discussion of problems.
Yeah, just curious, what do you think what's the biggest threat to your civilization that you humans are going to have to take care of in the next century or so?
I think the greatest weapon of mass destruction that has emerged is social media.
Whoa.
And I think that is for me, and I've thought about this a bit, I think that is unquestionably the biggest threat.
Can you elaborate on that?
I think the access to information without the ability to process that information, while knowing that that information is actually modifying the brain of the beholder. We know that it is modifying them. It is modifying their ideas. It is modifying their beliefs, which not inevitably, but in large part is likely to modify their actions. We've seen examples of this in recent US history. And I think that this is a trend that I'm afraid it will continue. And I'm afraid that in a kind of a laissez-faire system where the approach is that you let the market decide. Well, the market has decided it's very profitable for social media to exist.
Well, this goes back to what you were saying about affect, right?
Correct. Exactly. That ties into that. And that's kind of, like I said, I've thought about this quite a bit. I think about this with other colleagues of mine. And I think that as I see it, social media really is, I think, the new weapon of mass destruction. Atomic power was the same way. Atomic energy has enormous benefits. It has exerted enormous costs, but atomic power was different in that its organization, its dissemination. First of all, it's very difficult, and it's much more controlled. I think social media is completely uncontrolled right now, and
so monolithic, right? It's like one company.
And I'm afraid this has the power to consume us. What the solution is, unfortunately, I don't know. I'd be I have solutions, but again, I think those would be not, they would not be possible to implement or would be seen as unpalatable.
What can you tell us what they are without us holding you to them?
Wild speculation.
I think very, very active policing of misinformation. So information, opinion is not information. I frequently hear people say, well, you can have your opinion and I can have my opinion, and we have to respect each other's opinions. Actually, that's not true at all. Opinions that emerge without actually careful deliberations of the facts. And facts, there are some things like facts. These are not, they don't have to, you don't have to say that they have to be agreed upon. Facts are facts. And so you don't actually have to respect everybody's opinions. And I think some amount of policing of badly derived opinions, how that would be implemented is, we can come up, actually, if you really sat down and thought of it, you can come up with a reasonable implementation of that. But I think that some reckoning has to come. And if that reckoning doesn't come, I think the problems that we have seen in the recent past are only going to be multiplied manifold.
The scary thing is the same policing might be used to blot out very valuable perspectives.
I agree. I agree, which is why this is really not a problem that can be thought of cursorily or where an answer can be arrived at easily.
Well, I think you humans will figure it out.
And we'll help.
Well, if we don't, you guys are okay because you don't live on Earth anyway. So
We like you guys. We're going to do what we can to help.
Yeah, exactly.
Well, thank you so much for all the time that you gave us. And
it's my pleasure.
These are so many fascinating ideas we're going to have to just stew on in the weeks to come.
Well, there's certainly a lot of cud that we have to do. Whether we can digest them or not is a different question. But then, as they say, cows don't really, they chew on a lot of cud, but they don't digest all of it. So maybe that's not so bad.
That's a fascinating insight.
Where can our human listeners find you at? What are you working on next, and what can we expect in the future for you?
We have a lot of different projects that we work on. We are working on certain theoretical papers on the intersection between the conscious brain and the unconscious brain. With my colleague Auto Music and I are working on that. We have planned studies, neuroimaging studies, where we hope to eventually get them off the ground, where we hope to train individuals in some aspects of the Wim Hof method, and then to kind of a pre and a post image assessment using functional magnetic resonance imaging and positron emission tomography to see whether there have been modifications in some of the functional neurobiology of the brain.
Cool. And where can people follow your work? Do you have a lab website or?
No, I don't do much social media or.
Makes sense.
You can
just
look
out for the
up my
literature.
name. You can look up my name.
Go right to the source.
Yeah, you can just look up my name. We have studies. We have a lot of studies. You can look for our papers on PubMed.
Perfect.
And many of those papers now can be downloaded, even if individuals don't have subscriptions to the journals. The National Institutes of Health actually will make, in some cases, available a preprint of the paper.
Very cool.
For individuals. We have a lot of different projects in areas like schizophrenia, obsessive compulsive disorder, mood disorders, borderline personality disorder. We're studying the kind of the genetic characteristics of the functional biology of twins with colleagues overseas in Italy and in Switzerland. So we have with colleagues in Budapest, we're trying to understand delayed dynamics in brain networks from functional MRI data. We have a book coming out with a colleague in Germany where we have several chapters that give insights into some of the methods that are used to study brain dysfunction in neuropsychiatric illness and some of the results and some of those implications. So all of this, again, it's kind of public can see that on different search engines, but I don't have any kind of social media presence of any site. So
Very cool. We'll link it so that people can find it.
Yeah.
Okay.
And we'd love to talk to you after you've learned some more information about this paradigm.
well, thank you for trying to demystify science. I think it's important that people understand that science, it's not some sort of magical act. It's a human endeavor, and it's fraught with pluses and minuses, and you have to kind of understand the process. And that's kind of what I try and teach students is once you understand how to think about doing science, that places you better to understand what the meaning of doing science actually is.
Yeah.
That's beautiful.
And there's no easy answers. It's
No, there-
difficult. You got to dig in,
Yeah, absolutely. Yeah.
but you can do it.
Gotta get dirty.
All right. Thank you so much.
Well, thank you. Good luck in your endeavors, and feel free to visit us anytime again.
Thank you so much.
Thanks.
Bye.
Okay, bye.